Let's look at the container-based workflow, which involves Docker, Kubernetes, Docker Compose, and how it is used and how where does it fit in, where each of these tools really fit in. We're going to begin with your source code. Typically, your source code might be in the Git repository, and then you clone it locally. This is a development workflow. How it will flow from development to production is what we're talking about. Now, using the source code, you typically write a Docker file and create an image for it with your application and the runtime required for it. Let's say you build a version 1 of the image, then you can test run it locally. Either you can use Docker run commands, or let's say if your application needs a backend service such as DB, or if you just want to automatically set up your application, create those environments, you could also use a tool such as Docker Compose. Docker Compose is extremely useful to set up application stack locally and test run it. Once you test it and find it okay, you can publish the image to the registry. Let's say you publish the version 1 of your application image. Now, how do you take it and deploy it in a production like environment? A staging or a production environment is what we are talking about, because what we saw so far is part of your continuous integration environment or the development environment. How does it work in a prod like environment is where you would use typically a system such as Kubernetes, which will help you to do the continuous delivery and deployment and so on. In a Kubernetes environment, you typically would write some YAML files, and that's where you define how you want to deploy your application. And some of the configuration would include which image to use and how many replicas or instances of that application that you need. So you feed in this YAML file to a command such as kubectl, kubectl or kubectl apply or kubectl create command is what reads this file and then sends it to the Kubernetes API server, and then it gets deployed in this multi-node environment. When you provide that command kubectl apply, it goes to the API server, then the scheduler gets called, and the scheduler is the one which then decides where to launch these containers, which nodes it runs on, and how it gets how it is run and so on. So let's say the scheduler decided to run it on these 3 nodes. So 4 instances of 4 replicas of that application are now running on these 3 nodes. Now let's find out what happens next, and this is very interesting because it's not gonna be one-time deployment that we're doing. We might make changes to the application. So when you make a change from a development machine and when you update the source code, what happens then is the image build will get triggered again, the Docker container image, Docker image build, and you will build the version 2 of the image. You can then deploy it in a local environment. Again, this is where Docker Compose is useful because you can just run one command, Docker Compose up, and then it would redeploy with version 2. Once you're done testing that image, you can then again publish it to the registry, your second version or V2 of that. Now, how do you deploy it? It's not an automatic deploy. You have to then make that change in the deployment file or a YAML file on Kubernetes side as well. And typically you would update the version of your image from V1 to V2 and then run kubectl apply command again. And along with the images and replicas, you would have also defined a deployment strategy. Could be a rolling update, in which case it would start deploying in batches. Let's say the first batch is the 50% of the capacity, the 2 containers out of 4 get replaced, and then it goes and proceeds with the next batch. Now it has deployed it with the new version. All 4 containers are updated. When the containers get redeployed, it can also come upon a different node too. And that is the entire workflow, right from where your source code is until it get deployed in the Kubernetes environment. And every time you make a change, you will follow the same cycle. On the left hand side, you have a continuous integration process where every change triggers a build. You can run a test locally, then you can create an artifact, in this case it's an image, and publish the artifact to the registry. That is the continuous integration part. And if you want to also do the continuous deployment or delivery, either of that, there is a slight difference between the two, but both will involve deploying it to a production environment. On the right hand side, a Kubernetes environment where you would update the configuration, apply, and the deployment would know what strategy to use, whether to do it in rolling updates, or batch updates, or whether to recreate, in which case with downtime. If you use a rolling update, it is typically also called as a zero downtime deployment. So you can uh, codify the deployment process on the Kubernetes side. That's the continuous integration and continuous delivery workflow for with Docker and Kubernetes.